Previously, we made this 3D printed RC skid steer, and it's great for building and destroying small structures. Though when it comes to moving stuff further than a foot, it leaves something to be desired. Which is why the goal of this video's project is a small but very capable 3D printed RC vehicle that pairs nicely with the mini skid steer, so that it can help transport objects over a larger distance, aka from one side of my desk to the other. But let's not beat around the bush here, okay? There's an obvious choice when it comes to choosing something that falls into this criteria. We're building a dump truck. But there's a lot of different types of dump trucks. I mean, let's just take a look. Dump truck, dump truck, dump truck. But none of them compare to the dump truck. I mean, just look at all that room for activity. We could easily fit a mini skid steer back there, if not 2 mini skid steers. With that deciding factor, let's figure out how we're actually gonna make this happen. First, to get an idea of what the truck is going to look like, I started by laying out this simple 2D sketch. Just like with the mini skiddy, I wanted to have a cartoony look, so I tried enlarging some features such as the wheels and dump bed. I extruded the chassis into existence first, as this would be what all the other parts centered around. I then proceeded to split the master sketch into all the different parts such as tires, chassis, dump bed, and pivot points. Now, my initial master sketch might have proved to have been drawn too hastily, as the first potential problem I realized was the space actually available for electronics. Though I did make sure to add around 55mm of space in the front under the hood area to keep the ESP32 and battery system. After which I decided to send it and print out the chassis to see how things would fit. I find it's really easy to get frozen in the cycle of trying to logically lay everything out in CAD versus printing out a simple mock-up version in the beginning, which gives you a hands-on feel and requires less brain power overall. With the mock-up 3D model in hand, I wanted to lay out the printed circuit board so that it could efficiently hold all the electronics, including the ESP32 development board, H-bridge, boost converter, and most importantly, the battery. I'm going to be experimenting on this project by attempting to use this Phoenix lithium-ion powered flashlight battery. Thank you to @CrabRC on my Discord server for finding these and recommending them. The reason why it could potentially be a much better solution than other lithium-ion batteries are that it has built-in circuit protection, overcharge and discharge protection, as well as when it comes to charging, you don't need any external charging device, as it just has this built-in micro USB charger that you just plug in and you're off to the races. Also, unlike many other battery options of this size, this is capable of putting out 2.5 amps steady, meaning that we could peak above that, but compared to other batteries this size, which average around 4 to 500 milliamps, this is definitely the clear winner. So it'll definitely be interesting to see how this holds up in the dump truck. My initial printed circuit boards arrived the following week. Upon opening, soldering, and testing, they proved to be a success, though I quickly learned that the original 5-volt boost converters I ordered were not going to cut it, because they kept shutting down whenever both servos would lock up at the same time. After many hours of searching on good old AliExpress and Amazon, I stumbled across these little guys and ordered 15 of them. The main difference are that these are rated at a higher output current, so shouldn't shut down when both servos are stalled. Now I just have to wait for them to get here. While waiting for the boost converters to show up, I tried to complete as much of the functional 3D models as possible, just going off general measurements. This model is sadly only 2-wheel drive, but it does have dualies in the back if that counts for anything. The drivetrain is just a direct drive off this 100 RPM N20 motor, which proved to be a little bit slow, so I'm going to try out a 500 RPM motor. I had originally wanted to use bearings on this project, but after looking at dimensions, it would have made it hard to keep the axles as strong as they currently are, while also keeping the same small form factor. Plus, it's one less thing to worry about. One of the trickiest parts of this build was designing the steering linkage, which I've never done before, as I've always done tank steering, which is dead simple. For example, to turn left, you run the left motor backward and the right motor forward, causing the vehicle to turn left. For the steering on this project though, I essentially had to split it into 3 different parts. The steering control arms, which separated the wheel away from the body so it could turn, a simple form of steering knuckle, and then a connecting tie rod to connect the steering knuckles. This is iteration 5 or 6 of the main chassis, which holds all of the electronics. The biggest change from Gen 1 to Gen 5 or 6 was the fact that I had to stretch the chassis by about 1 centimeter to allow room for the steering linkage and servos, as well as a place for the wires to run. Luckily, the main chassis is still super easy to print, as all of these parts are built with 3D printing in mind. You just need to make sure to apply supports under this overhang on each side, as this is where the steering linkage moves in and out of. Coming back to the printed circuit board, you'll see that the Phoenix battery sits nicely on top, which is just super satisfying, as everything is now contained in a nice little unit. Also, speaking of which, I finally got those other boost converters in and they work great so far, but will be subject to much more testing. Just like the Mini Skiddy, this project is controlled using an ESP32 development board, which hosts a web page that acts as a controller. This web page can be accessed from your phone, tablet, or laptop by going to your Wi-Fi connections, connecting to the Prof Boots mini dump if you've uploaded my code, then opening your web browser and typing in 192.168.4.1, which is the default IP address of an ESP32. The controller will then be displayed and you're ready to rumble. The code for this controller is all open source and linked below, so if you'd like to add more buttons or change it to your liking, please be my guest. It's all written in the Arduino IDE, which is super user-friendly and a great way to start out if you're looking to test out your coding capabilities. Though I would like to show off my sliders on this controller versus the Mini Skiddy controller, as it just makes for a much more interactive driving experience, in my opinion. On the left we have throttle. The closer to middle you are, the slower you're gonna go, and then if you move it all the way up, you'd be going pedal to metal, and then if you moved it all the way down, you'd be going pedal to metal, except in reverse. This works by using a PWM pin on the ESP32, pulse width modulation, and you're writing a value between 0 and 255 to that specific pin. 255 would be max speed, and 0 would be no movement at all. On the right we have steering, and then in the middle we have the bed dump up/down motion buttons. There's also an aux button which can be set to whatever you like, whether or not you want to add a light bar or a horn or both. If you want to add more buttons, be my guest. I'm guessing that in the 2.0 version of the mini dump truck there will be more buttons, as I will be adding some auxiliary features. But just keep those in mind when you're thinking about upgrades. After assembling the base of the mini dump, it quickly became apparent that there was a major issue. The fact that the TPU 3D printed tires have 0 traction. Whereas I got away with this on a Mini Skiddy because it was 4-wheel drive, this is only 2-wheel drive and made it nearly impossible to move. Along with that, the front tires kept binding up every time I tried to turn them a little left or right. To solve issue number 1, I tried initially sanding down the tread on the tires to maybe give them a little bit more bite and remove the slick surface. This worked a little bit, but certainly not well enough. Next, I tried coating the outside in a little bit of hot glue. This helped a tremendous amount, but I had a feeling I could still do better, and not everybody wants to deal with a hot glue mess. So I picked up these rubber O-rings at a local hardware store for super cheap. I think I got this whole kit of 400 for $7 some, and inlaid these grooves into the tires for them to sit. This worked extremely well and made this little guy an off-roading beast. For those of you wondering, the outer diameter of the O-ring is 42 millimeters. For problem number 2, I realized that the front axles were binding on the screws that held what acted as the upper and lower control arms on. I simply increased the gap by 0.5 millimeter by shaving away some material on the axle itself, then also shaved away some more material on the control arms to give more room for the wheel when turning. As seen here, all of these solutions ended up helping tremendously with the ability to actually drive around, which leads to adding the dump bed. Now of course, since it's the main purpose behind this project, it needs to be adequately sized. This thing feels largely unproportional to the rest of the truck, but I absolutely love it. It just feels like it's blundering around when it's driving. To move it up and down, I slapped another servo directly on top of the steering one with a support that not only anchors it down, but also the drive axle cover and the dump bed pivot point, all with one screw. Now that's called efficiency. Finding the correct distance away from the pivot point and arm length to maximize the strength of the dump bed servo took a minute, but once I did find the optimum angle, it worked pretty well. To cover up the electronics in the front, I made this hood that can pivot so that you have easy access to the on-off switch as well as the battery so you can recharge it. Have I mentioned that I love this battery setup? It's perfect. I get about 15 minutes of casual runtime, though I did run a test where I just ran it in circles at full throttle for as long as possible, and it lasted about 10 minutes. Keep in mind this was without any servo movement, which can hog a lot of power when under load. Then I just popped the hood, popped the battery out, plugged it in via micro USB, waited for it to charge, or if you have an extra, I just popped that one in instead, closed the hood, and you are ready to go. The Phoenix batteries are about $7 a piece, so I recommend just picking up 2 or 3 while you're at it. Wire management is always a bit of a problem with these small projects, mainly because there just really isn't anywhere to put it. Luckily, I have this nice gap between the ESP32 and the sidewall of the main chassis, which I'm able to shove extra wire into. Definitely be revamping this circuit board to optimize wire connection locations, as well as just make the board slightly smaller. So I'm going to wait to make the printed circuit board open source until I've done that, so you can expect a release of the circuit board with Mini Dump 2.0. For some much needed detail, I designed and printed off these cab and railing parts. I found for super small features like these, I like to use TPU because it's just a lot more durable, and if you're using the 95A variation like I am, it's still pretty structurally sound. I didn't use any support on these railings, which caused a little bit of stringing, but in my opinion isn't too bad and is worth not having to shave away excess material. On the side, I made these simple storage containers. I would like them to actually be able to hold something in the future, but I'm gonna save that for Mini Dump 2.0. Finally, putting everything to the test, I decided to set up a little 2-person work site with the goal being to move all of these Jenga blocks from one side of the area to the other, using the Mini Skiddy to load and the Mini Dump to transport. Oh, and I also swapped the 100 RPM motor for a 500 RPM motor. I think somewhere around the 200 to 300 RPM variation would be optimal, as the 500 RPM variation doesn't quite have as much torque as I'd like. But for now, this thing does pretty good for being made of 3D printed parts. I love how this project turned out, and it absolutely cracks me up to see it blundering around on the floor, and it turned out to be surprisingly functional. I will of course be making this a kit for all of you who want the parts and pieces without having to source all the different components. Though in good development fashion, I will be doing some more work on it for the Mini Dump 2.0 version, which you can expect to be released in about 2 to 3 weeks. So if you'd like to support the channel, consider pre-ordering the Mini Dump kit or checking out the Mini Skiddy. Thank you so much for watching, and I'll see you in the Mini Dump Truck 2.0 video.